is the midpoint of segment AB, then guess what we know? If M is the midpoint of segment AB, what does that tell us?
That A to M is equal to N to B.
AM equals MB. I mean, the length equals the length. Okay, that is the definition of midpoint. I think we did that in chapter 1, maybe mentioned that, midpoint. Okay. Now, similar, this is the definition. If M is the midpoint, then those two will be equal. There's a midpoint theorem as well. I think we might have mentioned this also. I'm not sure though. Shh, boys, hush. Okay. How does the length of AM compare to the length of AB? How does the length of AM compare to the length of AB? It's half. AM is half of AB. So that is a theorem because you can prove it using some like algebra tricks. I'm not going to do that right now, but it'll be a very short theorem. Okay, now here's something that's new. Anything that goes through the midpoint of a line segment is called a segment bisector. So it could be a line, it could be a ray, it could be a line segment, but anything that goes through the midpoint, if M is the midpoint, is called a segment bisector. Okay, because what does bisect mean? You guys have bisected a frog in science? Not just cut it open. Bi means two. It's to cut it into two equal parts. Bi means two, sec means cut, basically. So bisector means cuts it in two equal parts, to be specific. Okay, so segment bisector. There's also one for an angle bisector. What do you think an angle bisector would do? Cuts in two. So if AD, so it'd be like a ray. If ray AD bisects angle BAC, then guess what we know? Angle 1 is congruent to angle 2. Okay? That would be the definition of angle bisector. So we have a segment bisector that cuts the segment in half, and we have an angle bisector that cuts the angle in half. Alright. Cutting them into two equal pieces. Not too complicated, right? Can we make it complicated? Can we find a way? So, does anybody want to guess what the angle bisector? So this is the definition of angle bisector. If segment or ray AD bisects angle BAC, then the two angles are the same. They're congruent. Does anybody want to guess what the angle bisector theorem says? You might be able to guess based on the midpoint theorem. Anybody want to guess?
ABD plus BAC equals BAC.
No, that'd be more like the angle addition postulate. So the midpoint theorem said AM is half of AB. Right? Makes sense, right? AM is half of AB, or MB is half of AB. So the angle bisector theorem says the measurement of angle 1 is half of the measurement of angle BAC. Makes sense, right?
Yeah.
If this is right in the middle, this will be exactly half of the whole. So angle 1, half of angle BAC. All right. If two congruent angles are bisected, then the four resulting angles are congruent. Not that important, I don't think. All right, page 100. We made it to 100. Time to celebrate by doing a math assignment. Number 1 says find the length. We actually did this on chapter 1 too. There's a little bit of repeat here. How do we find the length of FC from F to C? You guys remember how we did that? Nobody remembers how to
Add up
find
the
the
numbers, like, and make them go positive.
Okay, guys, that's your last warning. I think I've had you move before, so if it's again, it'll be a permanent thing.
What?
Screwing around in class. I don't care who did it, it doesn't matter. We'll separate you. I forgot what I was talking about. Oh, from F to C. So, how do we find the distance from, like, say somebody's 10 and somebody's 64? How do you find the age gap? Subtract. Okay, what if you're going from like 7 to -5 though? You still subtract, because what happens when you subtract a negative? It turns into like a plus. So the distance from 7 to -5 is 12. What if you subtracted backwards though? You get -12, so you just have to make it. Distances are not negative, okay? It's not -40 miles to Tulsa. So you just make it positive. If you do the big number minus the smaller number, it always comes out positive. If you subtract backwards, it comes out negative, but you make it positive. All right, so how far is it from F to C? What is the coordinate for F? 4. What's the coordinate for C?
-6.
So 4 minus -6 is 10. So basically from 4 to 0 is 4. From 0 to -6 is 6. So that's why it's 4 plus 6. Okay, HG, so H is at 10, so 10 minus 6. And BD, where's D at? It's right next to -3, -2. So from -2 to -9. So let's say I subtracted the wrong direction on this one. -9 minus -2 would be -9 plus 2, which is -7, but then you have to do the absolute value. So let's make it 7. Okay, 3 says find the midpoint of segment FH. So F is at 4 and H is at 10. So how do we find the point, the coordinate of the point? That's what number would be right between 4 and 10? How would we find it? There's a harder way and an easier way. Anybody think they might know the harder way, I'm guessing? How do you find a number right between 4 and 10?
Subtract, 4 from 10.
Okay, that'd be 6. Is that?
Add it up and divide it up.
Okay, if you found the distance, 6, cut it in half, 3, and then what would we do with that? We could do 10 minus 3 or 4 plus 3, 7 would be in the middle. There is an easier way. Does anybody think they know the easier way? Okay, if you get an 80 and a 90 on your 2 tests, what's your test average?
85.
Okay, what is that doing? It's averaging. That's what averaging does. So how do we average 2 numbers together? You add them together and divide by 2. That's the easiest way to do it. Okay, you could do 10 minus 4 is 6, half of 6 is 3, 4 plus 3 is 7. That's the last step. So to average 2 numbers, you add them together and divide by 2. That just tells you the number that's in the middle of other numbers. It's kind of how your grades work. Number 5, that's how a lot of things work. Which is the midpoint of CG? So C is at where? -6, and G is at, you guys probably know this one without even averaging. What's right between -6 and 6? Oh, does it say that? It doesn't say the coordinate, it says the point, doesn't it? Yeah, the coordinate would be 0, right? 0 is right between -6 and 6, but the point is E. Coordinate is a number, the point is labeled with a letter, capital letter. Okay, well, we're not doing 7, are we? We're going to,
Numbers.
can you guys see the assignment over there? Oh, it does say 1 through 9. Oh, yeah, whoops, okay, we already did so. Okay, if B is the midpoint of segment PQ, so my advice is, draw this out. So segment PQ will be this, and did they say B is the midpoint? Okay. Yeah, and then it says PQ is 24, so where should I put the 24? Maybe right in the middle. You could like label it like this if you wanted to, but 24 is all the way across. And then PB is 12. Okay, this is a true or false question. If the whole thing is 24, is PB going to be 12? True or false? Sure. Okay, number 9. SX equals 1/2 of SR. Oh, this is a trick question. Bummer. Okay, well, you might draw it like this. If SX, well, if it's half of SR, what would SR maybe look like?
A longer one.
It'd be longer. It has S in it, so where should maybe the R be? No. SX is 1/2 of SR, so SR is twice as big. Okay, well, you might think, okay, R is over here, but is R necessarily right there? Could be down here. Okay, and it matters because of their question. The question is X the midpoint? Well, if R is over here, is X the midpoint?
Yes.
If R is down here, is X the midpoint? No. So it matters is X between S and R. They would have to say that. So R could be anywhere, so this would actually be false. I guess I just put an F on the last, or T on the last one. Does that make sense? It's kind of a trick question.
Is that what it is?
Maybe, didn't really look at it. If AX equals XB, then X is the midpoint. Yeah, if AX and XB are the same length, does that mean X is necessarily right between the two? Because what else could it look like? This is A and this is B. If the length from X to A and X to B is the same, does X have to be right in the middle, or could it be up here? Could X be up here and these two still be the same length?
Yeah,
Yes. So is X necessarily the midpoint? No. Yeah, I kind of skipped that on the definition. For it to be the midpoint, it's got to be right in the middle. So it has to be between A and B. It has to be on the line segment between A and B. And if they don't tell you, you don't know, so it'll just be false. All right, we're not doing 11. We are doing number 17 next. Find AB if X is the midpoint of segment AB. So drawing pictures will probably help. Here's segment AB. X is the midpoint. AX has the given length. Number 17 says 157. So if AX is 157, okay, the direction said find the length of AB. So how am I going to find the length from here all the way to here? 157 plus 157, or 157 times 2. So it's 3, AB equals 300. not too hard. It's, the tricky part is like making sure you're understanding what they're saying. Where is X at? Where is AB at? What's the picture look like? Once you know what the picture looks like, it's like, oh, there's just two of those to make AB. So, not hard once you translate it. 19, given the coordinate M is the midpoint of segment AB, so it starts off kind of the same. M is the midpoint of AB. And the length of MB, so they're going to tell us the length of MB. Find the coordinate of A and B. All right. So this one's more confusing. 19 says M equals -6. What is that standing for? Yeah. So it says given the coordinate of M, so the little m must be telling us the coordinate of M is at -6. And then it says MB equals 3. So what does that mean? That's the length. So if the length from here to here is 3, what's the length from here to here? Also 3. Okay, but the question is, what must the coordinates of A and B have to be? So you got to kind of think of it on a number line. If this is -6 and you move 3 to the right, what would the coordinate for B? -3. So basically it's -6 plus 3, -3. And how would we find the coordinate for A if we move 3 to the left? -9. So that's kind of like -6 minus 3. We're going 3 steps backwards on a number line. So it's -7, -8, -9, -5, -4, -3. So -3 and -9 are the coordinates. That is all. Are we doing 21? Whatever. 27 is next. Jumping around. We're actually not doing a ton of problems. Jumping around so much. 27. Solve algebraically. Sketch a number line, illustrate. So, kind of basically show your work, kind of like I did on 19. Find the coordinate of R if the midpoint of RS is -1. Okay. So, RS, the midpoint, let me put those on top. The midpoint, they said, I don't think they named it, but they said the midpoint was at -1. I'll call it M. Okay, and the coordinate of S is 5. You guys follow that? Coordinate of the midpoint is -1, coordinate of S is 5. So the question is, what is the coordinate for R going to be? Okay, how far is it from 5 to -1, or -1 to 5?
6.
It's 6. You could do what we did on like number 1. 5 minus -1 is 6. So it's 6 from here to here, so if M is the midpoint, it's going to be 6 from here to here. So you could do -1 minus 6, going backwards 6 steps. And that would be -7. So these numbers I put on the bottom are the coordinates. That tells you a number that tells you the location. The numbers I put on top here is the length from M to S. 6 steps from M to S, so it's 6 steps from M to R. coordinates of the endpoints, so we got two endpoints we're looking for, M and N. The midpoint P is at 2. Kind of the same picture all the other ones. Wait a second. Hold on. I didn't write that down right. Oh, sorry guys. I meant to do 25 to 30. I knew I was missing something. Oh no. It's so hard. Easy. Never easy. Okay. My bad. I didn't copy it very well. Okay, P is the midpoint, and what else are we saying? Coordinate P is 2. And then it says Pn equals 19. What does that mean? Pn equals 19. That means the length from P to N is 19. So that means the length from P to M is 19. Because P's in the middle. So how do I find the coordinate for N? Two plus 19. 19 to the right. So it'd be 21. How do I find the coordinate for M? So going backwards, it would be 2 minus 19. Going back to the negatives. So it would be negative 17. Okay, back to 25. Well, guess what? UW is an angle bisector. Surprise, surprise, surprise. So if UW is an angle bisector, what do I know about these two angles? They're the same. Angle bisectors make the two little angles congruent. So if these two are the same, how do I set up to solve for x? If these two angles are congruent, how do I set this up to solve for x? Yeah, just make them equal. Congruent means the same, equal means the same, so these two are equal. 2x minus 5 equals 3x minus 22. How do I solve when there's, how do I solve when there's x's on both sides? Remember?
X twice.
Manny?
You subtract 3x from 2x to get it on that side.
Right. You want to eliminate the x's off one side. You could subtract 3x on both sides, or you could subtract 2x on both sides, either way. I'm going to go with what Manny said. 2x minus 3x is negative 1x. Now what do I do?
Just subtract the 5. You add the 5 to negative 22.
Add 5 to get rid of the minus 5. How do I get rid of that negative?
You divide by negative 1.
Yeah, dividing by negative 1, all it does is switch the signs. So it'll go to positive 17. Okay, is that it? No, that's the answer to A. It's kind of like yesterday's. A is x is 17. B is asking for angle TUW. Angle TUW is that angle. So how are we going to find this angle? Going to plug that 17 in for x that we just got. So 2 times 17 is 34. 34 minus 5 is 29. Talking about an angle here, so that'd be 29 degrees. What do you think they're going to ask for C? You might guess wrong. Okay, you might guess angle WUV, which would also have to be 29. These two angles are the same. But I think they're asking for angle TUV, which is the big angle. So it would have to be 29 plus 29, or 29 times 2. So that would be, I'll just write it out, 29 times 2. So that would have to be 58 degrees. So on 26, the picture is a little bit misleading. Okay, you guys see those two red little arcs in the corner on the right side? Okay, when you have, they didn't draw it very well, but when you have arcs drawn in there, what they're telling you is that these two angles are the same. Okay? So this third angle over here doesn't really matter. We just need to know that these two angles are the same. So the way they drew it, it looks like one large arc though, but really what they're doing is they're saying this angle and this angle are the same thing. Okay, so basically this ray right here is an angle bisector. These two should be equal. So really it is the same thing as number 25.